Okay, this is also a wave on a string problem. So I got a string vibrating in its fundamental mode with the frequency of 220. 1 over seconds is the same thing as hertz, right? 1 hertz is 1 over seconds. Seconds to the minus 1, same thing. And it tells you the length of the segment has a mass of 1.2 grams. Find the tension in the string. Okay, so the first thing I need to do is get the velocity. This is kind of like that other problem where you had a phone cord. So I know that, let's see. I know that velocity is frequency times wavelength. So if I could get the frequency and the wavelength, I could multiply them to get velocity. And in my case, so yours is going to look different, but in general, for the when you're looking at harmonics, 2 harmonics equals 1 wavelength, right? So in my case, this is 1 wavelength right here. So this is 70 centimeters, and my wavelength is 2 harmonics, but 70 centimeters is 3 harmonics. So for me, what I would do is say, okay, well, my wave is 2/3 of this, right? Because see how there's 3 parts? So my wavelength is going to be equal to 2/3 of the length of the string, which is 70 centimeters. So it's going to be 2/3 of 70, right? And that would give me my wavelength. And then it gives me the frequency, right? So I can take wavelength times frequency, and now I have velocity, right? So yours may look different, but if you just use the same fraction, right? Just find 2 and find what fraction that is of the total and multiply that fraction by the length of the string, right? Easy. Okay, so that'll give me the speed. And again, once I know speed, now I'm just solving. Remember, we've rearranged it before in class, but it's mv squared over L, right? Because that's for the tension in a string, because the speed in a string is the square root of the force over the string density, and the string density is mass over L. So if you do some algebra and combine these two, you end up with this, right? That's just rearranging to solve for F. So here, look, I know V, so V can plug in. And I know the mass of the string, right? There's my mass. And I know the length of the string, and I've got enough to solve, right? Pretty simple. You just have to do 2 steps. You got to find V first. Okay. The second part of this says find the frequency of the string when it vibrates in 3 segments. Find the frequency of this string when it vibrates in 3 segments. So this has to do with fundamentals, right? So the frequency of an nth harmonic, right? N being some number of harmonics. So in this case, right, this is 1, this is 2, this is 3, this is n equals 3. So the frequency of the nth harmonic is equal to n, which is the number of harmonics you want, times the fundamental frequency. And so in my problem, the fundamental frequency was, I don't know it. I want the frequency of the strings when it vibrates. The fundamental is 220. Right? So 220 is going to be my fundamental, right? And I want the frequency of the string when it vibrates in 3 segments. So n is going to be 3. So my frequency of the nth harmonic is just 3 times 220, right? We did a lab like this. Every time you add a harmonic, you add a multiple of the fundamental frequency, right? That one's pretty simple too. So pretty straightforward problem.